Let's jump right into this. We are going way, way back today. Back to the absolute dawn of human civilization. We're talking about the world's first cities, the literal birthplace of writing, and these ancient Mesopotamian voices that have been trapped in clay for millennia. Seriously, for centuries, these voices have just been totally silent, locked behind a script that time basically forgot. But today, well, we're going to explore how modern artificial intelligence is finally giving them their voices back. 500,000. Just let that number sink in for a second. Right now, sitting in museum basements, university vaults, and private collections all over the globe, there are over 500,000 untranslated ancient clay tablets. It's like a giant puzzle just sitting in the dark. 500,000 documents detailing politics, economics, science, and just the everyday mundane lives of ancient people, completely unread. So what exactly are we looking at here? Well, thousands of years ago, scribes in the very first major cities, think places like Sumer, Akkad, Babylon, and Assyria, used reed styluses to press their records into wet clay. And the kicker here is that these tablets are literally the oldest written history in the world. They aren't just some ancient rocks. They are the earliest real-time data we have of human civilization functioning, recorded stroke by agonizing stroke in cuneiform. Now, you're probably wondering, if we have all this incredible history, why haven't we read it all? Well, it exposes a pretty wild reality, something we call the translation bottleneck. It's not that the text is completely impossible to read. We just literally don't have the human manpower. There are maybe a few hundred trained Assyriologists on the entire planet who can read cuneiform fluently. If we just relied on this tiny, brilliant, but overworked pool of experts, fully translating every surviving tablet would take centuries at our current pace. And keep in mind, before AI even entered the chat, human scholars fought an agonizing 220-year struggle just to figure out the writing system itself. The timeline is actually staggering. From the initial breakthrough discovery way back in 1802, all the way to 2022. Yes, 2022, when cuneiform was finally considered fully deciphered as a script. That is over 2 centuries of painstaking, manual detective work just to read the alphabet, let alone actually understand the nuances of the language. That whole incredible journey really kicked off with the Behistun inscription. Commissioned by the Persian king Darius I around 550 BCE, this thing is a massive carving on a sheer cliff face. And what makes it so absolutely crucial is that it featured the exact same royal proclamation in 3 different scripts: Old Persian, Elawite, and Akkadian. It basically functioned as cuneiform's Rosetta Stone. Old Persian was decoded first, and that provided the ultimate key to unlocking the other 2 ancient scripts. But hey, just knowing the script didn't magically make the languages easy. Scholars still faced these massive linguistic hurdles. Sumerian, for example, turned out to be a language isolate, meaning it has 0 known linguistic relatives anywhere in the world. It's on an island totally by itself. Akkadian, on the other hand, well, that was a bit more manageable once they cracked the pattern, because it's a Semitic language, so it actually shares a distant family tree with modern Hebrew and Arabic. Which brings us to a total game changer. In 2023, researchers from Tel Aviv University and Ariel University published a truly groundbreaking study in the journal PNAS Nexus. They successfully trained a neural network to translate Akkadian cuneiform directly into English, instantly. I mean, what took human experts 220 years to fully unpack, this AI system can now process in absolute seconds. No way, right? But it's true. But I know what you're thinking. How do we know this isn't just some tech gimmick? Well, in machine translation, they use something called a Blue 4 score to measure quality. The AI hit a 36.52 score for direct cuneiform to English and a slightly higher 37.47 when translating from transliterated text. To put that into perspective for you, these aren't just, passable scores. These indicate genuinely useful, high-quality translations that are accurate enough for scholars to actually cite in their academic papers. The system does have a sweet spot, though. It is absolutely perfect for formal texts. We're talking royal decrees, strict legal codes, astronomical omens. And why is that? Because ancient bureaucrats loved their predictable paperwork just as much as modern ones do. These documents follow really rigid, formulaic, and highly predictable patterns that a neural network can just gobble up and replicate with amazing reliability. But look, translation is only half the battle when you're dealing with artifacts that are thousands of years old. You also have to deal with the fact that they're broken. And that brings us to our next crazy number: an 89% success rate on a totally different problem that has plagued archaeologists forever. See, most of these 500,000 tablets are physically damaged, cracked, broken, chunks just missing. Enter the Babylonian engine.
This is a separate deep learning tool trained by Ariel University and Bar Ilan University. Honestly, think of it exactly like the autocomplete feature on your phone, but for ancient languages. It analyzes the surrounding context and predicts the missing or destroyed words with that 89% accuracy we just mentioned, actively reconstructing Persian-era tablets from the 6th to 4th centuries BCE.
Now, to be fair, we have to talk about the honest limitations here. There is a really stark contrast in how well the AI performs depending on the type of text. While those formal bureaucratic texts translate beautifully, the AI really struggles with literary and poetic texts, things like personal letters from priests or deeply emotional poetry. With those, the AI is way more prone to something researchers call hallucinations. Let's define exactly what that means in this context. An AI hallucination is when the system generates a fluent-sounding translation that is actually factually wrong and totally unrelated to the original text. It sounds perfectly fine in English, but it's completely off base. For culturally and emotionally rich texts, missing the nuanced meaning or just making up a false one is a massive problem. That's exactly why human verification is absolutely essential. And that leads right into the researcher's ultimate, and I'd say incredibly optimistic vision. The goal is not to replace human Assyriologists, but to build a human-machine collaboration pipeline. The AI basically acts as this tireless, ultra-fast assistant, handing scholars and students a remarkably quick first draft. Then, the human expert steps in to verify, refine, and really interpret those intricate cultural nuances that a machine simply can't grasp. So, why does all of this actually matter to us today? Because Mesopotamia's legacy is the literal bedrock of our modern world. The stakes here are immense. These people gave humanity its first cities, they established the very first codes of law, and they invented the first writing system. The historical weight of these records is just monumental. They literally shape how we understand human progress itself. For thousands of years, these incredibly human records have just been buried in the clay. We're talking royal decrees dictating the rise and fall of massive empires, business contracts trading grain and livestock just to survive the winter, letters from parents writing to their kids. All of these stories have been trapped in a 220-year translation bottleneck that is finally, literally right now, starting to break open. Which leaves us with this final, really provocative thought. 500,000 tablets hold the unfiltered, unread history of the dawn of human civilization. AI has finally handed us the tools to decode them at an unprecedented scale. So, now that we finally have the ears to listen, what will the first cities tell us next? Thanks for joining me on this explainer, and keep that curiosity alive until next time. All right, let's dive right into this explainer. We're going to see how artificial intelligence is basically acting as this incredible master key, unlocking the long-lost voices of ancient Egypt. Seriously, if you're even a little bit fascinated by the ancient world, we are living in a truly monumental moment right now. We're literally witnessing this wild convergence of cutting-edge deep learning and thousands of years of human history, and it is completely reshaping how we understand the past. You see, for over 1,400 years, this profound silence just kind of fell over the ancient world. The very last scribe who could fluently read and write Egyptian hieroglyphs passed away sometime around 400 AD. And after that, well, we were left with these massive temple walls completely covered in elaborate symbols that absolutely nobody understood, tombs filled with intricate spells that no one could decode. Basically, an entire civilization's voice was just sealed shut in stone. And it took a massive amount of time to even get our foot in the door. I mean, it wasn't until Jean-Francois Champollion's famous decipherment back in 1822, using the Rosetta Stone, of course, that humanity got its first real key. But today, the pace of discovery is just exploding. With the launch of things like Google Fabricius in 2020 and the Hieroglyphic Transformer in 2024, modern AI is now accelerating this translation process at a literal industrial scale. Now, you might be wondering, why do we even need AI if Champollion cracked the code 2 centuries ago? Well, despite that massive historical breakthrough, reading hieroglyphs is still one of the rarest skills on Earth. It takes a solid decade of intense training. Because of that, today, there are fewer than a few hundred fluent human experts in the whole world. That creates a massive bottleneck. We have hundreds of thousands of texts just sitting there entirely unanalyzed in tombs, temples, and museum archives all over the globe. So how do we actually fix this? Well, we do it by teaching a machine to comprehend the logic of an ancient language. Enter this fascinating 2024 breakthrough called the Hieroglyphic Transformer. And to be clear, this isn't just about scanning documents. This is about fundamentally teaching an AI to read exactly like an ancient scribe. Researchers took a specialized neural network and trained it to actually read ancient Egyptian. And the way it learns is just incredible. It doesn't rely on strict, rigid coding rules or some simple dictionary lookup. Nope. Instead, it learns visual and grammatical patterns by exposure. It trains on thousands of already translated inscriptions until it organically recognizes the patterns. It's effectively learning to think like an ancient Egyptian scribe. And the sheer complexity of what this AI is tackling, it's staggering. It had to master over 700 distinct signs. We're talking about falcons, reed leaves, owls, coiled ropes, the whole shebang. And these aren't just letters, right? Each symbol can represent a sound, a whole idea, or a clarifying determinative. To make it even wilder, scribes often combined these 700 signs in incredibly complex, non-linear arrangements, usually just based on aesthetics and spatial optimization. It's like a giant puzzle. The hieroglyphic transformer brilliantly shows us how neural networks can handle that immense complexity. It actually performs 3 intricate levels of analysis all at once. It looks at an inscription, recognizes the individual glyphs, figures out exactly where one word ends and another begins, which, by the way, is incredibly difficult when there's 0 punctuation, and then it translates the full sentence. And it does all of this completely simultaneously. But hey, this technology isn't just locked away in some high-tech academic labs. Back in 2020, Google Arts and Culture launched Fabricius, literally putting the power to translate hieroglyphs right in your pocket. They built this alongside Egyptologist Dr. Roland N. March from the University of Liverpool, and it really represents a paradigm shift. The tool lets anyone with a smartphone, whether you're a student, a tourist wandering around Egypt, or just a curious mind, snap a photo of an inscription and get an instant translation in Arabic or English. It totally transforms what used to be an elite scholarly skill into a truly accessible, everyday tool. And behind the scenes, the tech just keeps evolving at breakneck speed. Researchers from the AIR Institute have been building these comprehensive computer vision pipelines for SIGGRAPH 2025. Basically, the system takes a photograph, converts it into standard Gardner sign codes, processes the transliteration, and then spits out the full English translation. It displays all these layers of translation at once, which makes it an unbelievably powerful way for researchers to step-by-step verify the machine's logic. So what does this all mean for us? What are we actually discovering with this crazy new speed? Well, we aren't just uncovering the stuff you'd expect, like funerary spells from the Book of the Dead, temple records, or royal decrees. Because AI can process thousands of inscriptions in the time it takes you to make a cup of coffee, we are uncovering the rich, everyday lives of ordinary ancient Egyptians. We're reading love poetry, advanced medical texts, tax complaints, and literally ancient shopping lists. Because, yeah, even 4,000 years ago, someone had to remember to pick up bread and beer. Now, we do need to pump the brakes for a second. AI translation is definitely not flawless. We need to have grounded expectations here, especially when we're dealing with the limitations of a language that was in continuous use for millennia. These pattern-matching algorithms run into some very real walls. First off, Egyptian grammar changed dramatically over 3,000 years, moving through Old, Middle, and Late Egyptian all the way to Demotic and Coptic. On top of that, an AI trained on formal, pristine temple text, it's going to get terribly confused by an informal, hastily scribbled letter between workers. It also easily misreads highly metaphorical religious language, and, as you'd expect, it struggles immensely with stone inscriptions that have been damaged or eroded by thousands of years of weather. And that is exactly why AI is not replacing Egyptologists anytime soon. It is simply an incredible assistive tool. Researcher Sarah Parka hit the nail on the head when she described AI as a bonus set of glasses. It helps scholars prioritize which texts, out of the hundreds of thousands sitting in archives, actually deserve a human expert's immediate attention. So the future of this field? It's entirely collaborative. By doing the mechanical heavy lifting and churning out rapid first draft translations, AI frees up human experts. The algorithm spots the visual patterns, sure, but the human scholar steps in to add the essential cultural, historical, and human context. And that's something no computer model can ever just infer from symbols alone. Ultimately, what you should take away from this explainer is that by turning Champollion's original Rosetta Stone key into a massive technological master key, we are finally resuming a conversation that was paused 4,000 years ago. Every papyrus, every tomb wall, every broken pottery shard holds a voice. Ancient Egypt is not silent anymore. We're just finally learning to listen faster. As we look toward the future, the possibilities are honestly thrilling. Researchers are already looking to utilize this exact same machine learning technology in the jungles of Central America to decode the incredibly complex glyphs of the Maya. And that leaves us with an absolutely incredible question to ponder. Once we give these algorithms a new set of data, what other lost voices of human history will AI help us hear next? Today in this analysis, we're going to dive into one of the most fascinating and honestly stubborn mysteries of the ancient world. We are looking at a 4,000-year-old secret that belongs to the Indus Valley civilization. These were a people who built some of the earliest planned cities on Earth, yet their voices have been entirely lost to time. In this explainer, we're going to look at the cutting-edge technology, specifically artificial intelligence, that's currently racing to decode the Indus Valley script. We'll explore exactly why cracking this code has become the absolute ultimate obsession for historians, linguists, and computer scientists alike. And just to show you how high the stakes actually are right now, take a look at this number, $1 million. In January 2025, the Chief Minister of Tamil Nadu announced the staggering bounty, a story that was immediately picked up by major outlets like the New York Times and the BBC. This is a massive prize aimed at anyone who can successfully shed light on this Bronze Age civilization by finally deciphering their script. It's essentially sparked this massive, fresh wave of research interest worldwide. It's literally created a modern-day treasure hunt for ancient knowledge. I mean, really think about the weight of that for a second. $1 million for a single translated word. We are essentially looking at a 4,000-year-old cold case. And what's truly fascinating here is the sheer paradox of this civilization. The people of Mohenjo-Daro and Harappa were incredibly advanced. They had sophisticated drainage systems, perfectly planned cities, standardized weights and measures. They were essentially mastering complex concepts thousands of years before anyone even coined the word engineering. And yet, despite over a century of intense archaeological research, not a single sentence of their writing has ever been definitively translated. No way, right? But it's true. So, you might be wondering, why is it so incredibly hard? Well, we face what I like to call the crime scene problem. Before we can translate anything at all, we hit an obstacle that is more basic than language itself. See, with settled scripts like Egyptian hieroglyphs or Mesopotamian cuneiform, centuries of scholarship eventually agreed on the exact inventory of signs. We knew the alphabet. But with the contested Indus script, we don't even have that basic foundation. Different scholars propose radically different counts. Some argue there are 400 signs, while others claim there are over 700. The core debate is that no one can completely agree on which carved marks are actual meaningful letters and which are just decorative or maybe accidental scratches. Imagine trying to build a dictionary when half the experts think a letter is just an ancient typo. We simply can't build a lexicon if we can't even agree on the alphabet. But this is exactly where modern technology steps in to do the heavy lifting. In 2025, researchers at IIT Mandi published an incredible interactive computational tool called AI epigraphy. This tool brilliantly illustrates how we're modernizing our approach to ancient history. Instead of relying purely on human interpretation, which, let's face it, is highly prone to debate and bias, this tool uses computer vision and statistical modeling to automate the identification of these signs. It's an unglamorous but absolutely essential first step. AI epigraphy is the very first fully automated attempt to settle the basic foundational question of what the Indus script's character set actually is. And let's look at how fast this technology is actually moving, because it's not just happening in India. Researchers at the Florida Institute of Technology, working under Professor Debasis Mitra, built something called ASR.NET. They are essentially teaching AI to actually see these ancient seals. Step 1, an AI called YOLO v3 detects exactly where an individual sign sits. Step 2, a system called MobileNet jumps in to identify which specific sign it is. You can think of it as optical character recognition, but for a completely unknown ancient language. And step 3, a companion system called MINet recognizes contextual images right next to the text, like unicorns or tigers. It is a rapid-fire, three-punch combo of machine learning that provides absolutely crucial visual context right alongside the text signs. Now, once these AI systems catalog the signs, we run into the most contested question in Indian history. What language were the Harappans actually speaking? So the crucial point here is testing what we call the prime suspect, the Dravidian hypothesis. This is the idea that the Indus script encodes a Proto-Dravidian language, which is the ancient ancestor to modern languages like Tamil, Telugu, Kannada, and Malayalam. Researchers have built these massive computational pipelines that take modern Tamil, convert it from its phonetic script into a logosyllabic form, meaning a system where symbols represent both whole words and individual syllables, which matches the structural style of the Indus script, and then they run statistical comparisons against the actual patterns found on the ancient seals. What's absolutely vital here is that AI is testing this hypothesis using hard data and pattern matching, completely removing human speculation from the equation. And look at how this timeline comes together to build such a compelling narrative. 4,000 years ago, the Indus civilization carves these mysterious seals. Fast forward to 2013, and population genetics research begins studying ancient and modern mtDNA and Y chromosome data, tracing a clear continuity in human populations over millennia. Now, in 2025, these AI-driven linguistic pipelines are matching data that could directly corroborate those genetic findings. We are seeing two entirely different scientific fields, artificial intelligence linguistics and population genetics, converging on the exact same historical question. If confirmed, this means the language spoken in South Indian homes today might be the direct descendant of the words carved onto those seals 4,000 years ago. That is just incredible. Okay, but I do need to bring us all back to reality for a moment. Despite all this incredible technological firepower, the script remains officially undeciphered. Why? Well, because of the missing evidence. There are 3 massive structural walls that AI simply cannot climb alone. No amount of computing power is going to magically fix these issues. They are incredibly short inscriptions, a complete lack of bilingual texts, and total ambiguity in how to even read the carvings. Let's break these down real quick. Wall number 1 is perfectly captured by this tiny number right here, 4.5. The texts are extraordinarily short. The average Indus inscription is just 4.5 signs long. Think of it like trying to learn the entire English language just by looking at a few random car license plates. 4.5 characters is barely enough data to establish any sort of grammatical pattern, let alone extract deep philosophical meaning or historical records. Then we hit wall number 2, which is the devastating lack of a translation key. You've likely heard of the Rosetta Stone, right? It's a bilingual document that famously allowed scholars to decipher Egyptian hieroglyphs by pairing the unknown writing system with a known one, in that case, ancient Greek. Well, the Indus Valley civilization has 0. There is absolutely no surviving bilingual text anywhere in the archaeological record that pairs the Indus script side by side with any known ancient language. And wall number 3 is perhaps the most frustrating one of all. We don't confidently know which way to read the text. Some inscriptions strongly suggest they should be read right to left. However, other seals seem to indicate a bidirectional reading, meaning reading one line left to right and the next line right to left. Without knowing which way to even start reading, every single statistical model generated by an AI begins on highly uncertain ground before translation even enters the picture. This brings us to a very sobering yet important realization. As researchers Rajesh Rao and Nisha Yadav have pointed out, AI provides extraordinary new analytical power, but it cannot manufacture context that simply doesn't exist in the archaeological record. We have to remember that AI is a phenomenal tool for pattern recognition, but it isn't magic. It cannot pull vocabulary out of thin air if the physical artifacts simply haven't been dug out of the ground yet. Every new excavation and every newly discovered seal adds critical data that pure computation just cannot generate on its own. So, what does this all mean for us? What should you take away from this? Well, for India, and really for human history as a whole, this is far more than just an abstract academic puzzle. The Indus Valley civilization is a foundational chapter of our global story, and the question of their language touches on the deepest questions of cultural identity. Were the Harappans the ancestors of today's Dravidian-speaking South Indians? Did they shape the civilization that later produced the Vedic tradition? Or does their language belong to an entirely separate, forgotten family with no living descendants at all? Every single technological tool humanity has ever built is now being pointed directly at this single question. And with tools like AI epigraphy and ASR nets getting smarter every single day, the answer to our oldest mystery may finally be within reach. Imagine holding a literal piece of history in the palm of your hand. We're talking about an ancient artifact that holds the very first recorded thoughts of one of humanity's oldest continuous civilizations. For well over a century, scholars have just been staring at these fragmented bones, trying desperately to unlock their secrets. Well, In this explainer, we're diving into how artificial intelligence isn't just speeding up that tedious process, it's actually completely revolutionizing how we understand the past. But to really wrap our heads around the sheer scale of this challenge, we have to start with one specific number: 3,000. Out of all the unique ancient characters discovered carved into these artifacts, an astonishing 3,000 remain a complete mystery today. I mean, think about that. Every single one of those undeciphered characters represents a lost word, a piece of ancient, everyday life that has just been totally silenced by time. All right, Section 1, the 3,000-year-old mystery. So picture this. Over 3 millennia ago, Shang dynasty diviners are carving their questions about wars, about harvests, directly into turtle shells. And today, we've discovered over 4,500 distinct oracle bone characters from those relics. But here's the wild part. Nearly 2/3 of them remain a total enigma. We absolutely know this script is the direct ancestor of modern Chinese, and yet roughly 3,000 individual signs simply cannot be confidently matched to their modern meaning. It's like having a massive puzzle where most of the pieces are just completely blank. Moving on to Section 2, AI draws the answer. Fast forward to 2024, and researchers at Huazhong University of Science and Technology decide to tackle this ancient problem with a very modern solution. They built the OBSD, or Oracle Bone Script Decipherment Model. And what's really cool is that instead of just wildly guessing, it uses a conditional diffusion model. Yep, that's the exact same underlying technology behind the AI image generators we use today. You input an unidentified ancient character, and the AI literally draws its predicted modern Chinese equivalent. And then, to make sure it's not just hallucinating, the output is verified using dual optical character recognition methods, including an awesome open-source tool called Paddle OCR. And the results? Honestly, they'll blow you away. We are talking about a phenomenal 99.87% recognition accuracy. When the AI proposes what an unidentified ancient character should look like today, independent verification confirms it's correct almost every single time. It isn't just matching shapes, it is genuinely learning the actual visual logic and evolution of Chinese characters across 3 entire millennia. Section 3, Fueling Discovery with Data. Now, as we all know, an algorithm is literally only as good as the information you feed it, right? Every great AI needs fuel. And for a long time, Oracle Bone Script research faced this massive bottleneck because researchers just lacked high-quality, organized image data. Well, that all changed in 2024 when researchers built and published the HUST-OBC dataset in Nature's Scientific Data Journal. This officially set the gold standard benchmark for all future decipherment models in the field. The sheer scale of this open-source resource is just staggering. We are looking at over 140,000 images. This includes over 1,500 already deciphered characters, and even more importantly, nearly 63,000 images representing over 9,400 still undeciphered character variations. So now, instead of starting from scratch in some silo, the whole world can build on this exact same foundation to rapidly speed up discovery. Which brings us to Section 4. Thinking like a scholar. Building on all that data, a stunning 2025 breakthrough elevated this tech even further, using large vision language models, or LVLMs. This is where it gets really interesting, because it created this brilliant contrast. You see, earlier AI models were often accurate, sure, but they operated as a black box. They gave you an answer, but absolutely no explanation for why they proposed that meaning. But these new LVLMs, they offer explainable AI reasoning. They actually justify their answers to human researchers, showing their work, so to speak. And the way the AI does this is by mirroring how human paleographers actually think. These LVMs analyze 2 vital features simultaneously. First, they look at radicals. These are the semantic building block components that carry the actual meaning in Chinese writing. Second, they analyze the pictographic resemblance to real-world objects. So when the AI explains, hey, I believe this character relates to water or grain based on these identifiable radical components, human sinologists can actually evaluate that reasoning. As you can imagine, that builds immense scholarly trust. But wait, it's not just about translation. There is also a literal, physical jigsaw puzzle to solve here. You see, oracle bones excavated a century ago were often completely shattered. Today, those fragments are scattered across museum collections on entirely different continents. Now, AI-powered fragment rejoining systems are analyzing breakage patterns, surface textures, and partial inscriptions to automatically match pieces that belong together. To put that into perspective for a second, done manually, that kind of work can take a human scholar years just to make a single successful match. AI is doing it in a fraction of the time. Finally, Section 5, reading China's first words. When we pull all of this together, the diffusion models, the massive open source data sets, the explainable reasoning, and the physical fragment reconstruction, we arrive at a massive emotional payoff. We are reconnecting with the ancestor of every Chinese character. The Oracle bone script isn't just some dead, foreign mystery. Whether you're glancing at a smartphone screen, a street sign, or a beautiful calligraphy scroll, the roots of that writing trace directly back to these very bones. We're talking about a writing system used continuously by over 1 billion people today. There's a quote that really hits the nail on the head regarding the philosophical weight of all this. It goes, "Every undeciphered character represents a lost word, a forgotten god, a vanished ritual." Nearly 3,000 characters are still out there, just waiting to be read. But for the first time in 3,000 years, humanity has actual algorithmic help. The gap between mystery and meaning is closing faster than ever before. So, I'll leave you with this truly profound thought to ponder. If cutting-edge diffusion models and vision language AI can reach back 3,000 years to successfully read the minds of Shang Dynasty diviners, what lost thoughts of humanity will AI read next?
Welcome to the Explainer. So, picture this. Deep, deep in the thick jungles of Mexico, Guatemala, and Belize, completely shrouded in mist and towering green canopy, lie the ancient pyramids of the Maya civilization. We're talking about a civilization that built magnificent, sprawling cities that easily rivaled ancient Egypt. But, what truly sets them apart isn't just their architecture. It's their written world. They created a writing system that is more complex than almost any other in human history. And today, we're going to look at how modern artificial intelligence is quite literally bringing these silent ancient stones back to life.
Okay, let's dive into this. Because to really appreciate the massive technological triumph we're seeing today, we have to first understand the sheer, devastating scale of the tragedy that happened centuries ago. When Spanish colonial authorities arrived, they systematically burned Maya books, by the hundreds. I mean, just imagine an entire civilization's history, their poetry, their incredibly detailed scientific records, almost entirely wiped out in colonial fires. It's heartbreaking. So what actually survived this profound cultural erasure? Just a tiny, tiny handful of bark paper books, some painted ceramics, and scattered stone monuments that were slowly being swallowed up by the jungle. And this loss? It's staggering when you realize just how brilliant these people were. ये लोग mathematics और astronomy में इतने advanced थे कि उनका calendar आज के calendar is ज़्यादा precise था. They were literally tracking the exact movements of Venus, the births and falls of dynasties, the endless sprawling cycles of time, and they recorded all of it. But trying to actually understand those few surviving records, well, that proved to be a monumental challenge for us.
Which brings us to part 1, a complex, erased language. Let's break down the massive hurdle scholars faced in deciphering this lost civilization. Maya script isn't like our alphabet, right? And it's definitely not just simple pictures either. It is this incredibly sophisticated, highly flexible hybrid system. Basically, it combines logograms, where a single symbol represents an entire word or concept, with phonetic syllables that spell out specific sounds. And to make it even more complicated, Maya scribes would stack these symbols together into these dense, totally irregular visual blocks. For a Maya poet or a scribe, this flexibility was beautiful. It was an art form. But for a modern scholar trying to systematically decode it, it was an absolute nightmare. A giant puzzle missing half its pieces.
But, human beings are persistent, which leads us to part 2, the 1952 breakthrough.
So you've probably heard of the Rosetta Stone, right? That famous artifact that finally unlocked Egyptian hieroglyphs because it had the exact same text written in both Egyptian and ancient Greek. It was a cheat sheet. Well, for the longest time, scholars studying the Maya didn't have one of those. It wasn't until 1952 that the Maya world finally got its equivalent. A bilingual monument was discovered at a site called El Peru Huaca in Guatemala, and it paired Maya glyphs with a much more familiar script. This was the exact spark, the false dawn really, that finally let researchers begin the systematic decipherment of the language.
And this brilliantly illustrates both the incredible progress and the eventual brick wall of human scholarship. Through decades, I mean literally lifetimes, of painstakingly slow, manual work, scholars managed to decipher about 80% of the known Maya glyphs. That's huge. But that remaining 20%, it remained a total mystery. These were the rare signs, the highly unusual combinations, the eroded blocks that just wouldn't make any sense no matter how long you stared at them. The decipherment process basically hit an insurmountable human limitation. We just couldn't cross that final gap. So what do? We change our tools.
Enter Part 3, Teaching AI to See.
Fast forward to 2024, and we get a massive breakthrough. Modern computer science finally stepped in to break this generational bottleneck. A team of researchers decided to attempt something totally unprecedented. They set out to teach an AI to automatically look at photographs of ancient, heavily weathered inscriptions and accurately find and separate the individual, densely stacked glyph blocks.
Now, the process sounds pretty simple on paper, right? But it was practically impossible at first. Step 1. They tried applying existing AI segmentation models. You know, the kind built for high-tech medical image analysis. But wool models completely fail, Hoge. They absolutely could not recognize the irregular, eroded shapes of the ancient stone glyphs. So pivoting to step 2, they had to do something incredibly tedious. Working hand-in-hand with Maya art and history experts, they hand-curated thousands of specific image and label pairs. They essentially had to manually teach the AI, block by block, exactly what it was looking at. Step 3. Only after that meticulous, expert-guided fine-tuning could these foundation models actually segment the glyph blocks accurately.
So why does this matter so much? Well, it all comes down to machine scale versus human memory. Even with all the surviving stones we have, many individual Maya signs appear very, very rarely. A human scholar, no matter how brilliant, simply cannot hold the entire surviving corpus of Maya text in their active memory at one time to spot a hidden, obscure pattern. But an AI, it absolutely can. AI solves this massive data scarcity problem by recognizing visual patterns across every single surviving inscription, everywhere, simultaneously. And honestly, image recognition is just a starting line here.
Which brings us to part 4, Claude and Unicode frontiers.
Now, what's really interesting about this slide is how different technological frontiers are converging all at once to solve this. First, large language models like Claude are stepping into the arena. Once the vision AI segments the glyphs, they're in its context or possible meanings मिल सकते हैं, it's effectively bypassing years of specialized graduate training just to get those initial translations going. And second, this is so cool, the Unicode Consortium is actively working right now to encode Maya glyphs into the International Digital Standard, meaning very soon you will be able to type, search, and share ancient Maya hieroglyphs directly on your smartphone or laptop, exactly like you do with English or emojis.
All of this incredible cutting-edge technology feeds into one vital mission, the Maya Hieroglyph Project. Supported by the National Endowment for the Humanities, the goal here isn't just academic. It's not just for university professors. They are building a publicly accessible, fully annotated digital archive. They desperately want to bridge this huge gap between a tiny handful of specialist epigraphers and the curious public. And most importantly, they want to open this history up directly to the descendant Maya communities themselves.
Let's look at part 5, The Stones Speak Again. We are living in a true moment of scholarly triumph right now. As the researchers note, and I love this quote, हर glyph block जो AI segment करता है, हर inscription जो Claude जैसे AI explain करता है, वो एक और टुकड़ा है जो वापस जुड़ रहा है. It perfectly captures the reality of what's happening. AI isn't replacing the dedicated, passionate scholars who spent their entire lives sweating in the jungle. Not at all. It is multiplying their reach. It's piecing together a burned, shattered history at a speed we literally never thought possible.
So, just to summarize this incredible generational quest, we start way back with the pre-colonial era, where this remarkably complex writing flourished, followed by that tragic erasure. Then, the incredibly long wait until the 1952 monument discovery gave us a foothold. Decades of painstaking manual work slowly bring us to the 2024 AI segmentation breakthrough, which just kicks the door wide open. And now we are heading straight toward a future with a global Unicode digital standard. We finally have the tools to listen to these ancient stones at a massive scale.
The Maya recorded the cosmos, the passing of great kings, the poetry of an absolutely incredible civilization. And we are finally reading those lost voices again, bringing light to a world that was almost plunged into permanent darkness. But, all this progress really makes you wonder, what other lost secrets are hidden beneath that thick jungle canopy? We know the writing is there, but what about the buildings themselves? In our next explainer, we're going to explore how LiDAR and AI are teaming up to reveal entire, massive, forgotten cities hidden right beneath the trees. It is mind-blowing stuff. Until then, keep questioning and keep learning.
Welcome to this explainer. Today, we're diving straight into how cutting-edge lasers fired from the sky are fundamentally rewriting human history. We are essentially living through a golden age of discovery right now. But, our explorers aren't exactly hacking through dense vines with machetes anymore. Instead, they're looking at data.
We're going to explore how a crazy combination of LiDAR technology and artificial intelligence is literally peeling back the canopy of the world's most remote locations to reveal completely lost ancient cities. We actually have to begin with a Spanish chronicler named Caspar de Carvajal. Back in 1541, he was traveling down the Amazon River, and he wrote down this incredible observation. He claimed the riverbanks were so packed with people that, quote, were a pin to drop from the sky, it would land on the head of an Indian. Now, the historical context here is wild. For nearly 400 years, historians completely dismissed Carvajal as a liar. They thought, oh, this is nothing more than colonial exaggeration or just pure fantasy. And that really perfectly sets up this massive paradigm shift we're experiencing right now. See, the 400-year-old myth, held fiercely by scholars, insisted that the Amazon rainforests could absolutely never support large, complex civilizations. The argument was always that the soil was just too poor for intensive agriculture, so people must have just lived in very small, scattered bands. But the new reality, totally validated by modern technology, is entirely different. Dense, complex, and highly sophisticated civilizations absolutely existed there. The jungle wasn't empty at all. It was a thriving metropolis. Turns out, Carvajal was telling the truth all along. It was likely the diseases brought by European contact that caused these incredible cities to just tragically collapse within mere decades.
Part 1. The Jungle's Hidden Secret, Uncovering the Upano Valley. Let's look at the undeniable proof that proved those historians wrong. When the very first laser data came back from Ecuador's Upano Valley, archaeologist Stefan Rothstein had literally just a single word to describe what was hiding beneath that dense jungle canopy. Wow. I love this because it so perfectly captures the sheer shock of the scientific community. They really weren't expecting to find much of anything, let alone what the data actually revealed. The sheer scale of this discovery was so undeniable that it was published in the prestigious journal Science in January 2024. This laid the incredible research foundation for everything we're unpacking today. They didn't just find a handful of scattered huts. It was definitive proof of an engineered landscape that defied everything we thought we knew about the ancient Amazon.
And a crucial point here is the timeline. These settlements date back at least 2,500 years. That's a full millennium, 1,000 years, older than any other known complex Amazonian society. We are talking about an advanced civilization thriving at a time when much of the rest of the world was still just figuring out basic urbanization.
And the density is just as staggering as the age. From just one single survey, researchers uncovered over 6,000 rectangular earthen platforms, plazas, and mounds. Think about that number for a second. 6,000 individual structures, all deliberately built and placed. So these definitely weren't random settlements. The Upano Valley featured highly planned cities spanning a massive 300-square-kilometer grid. We're talking straight roads cut at perfect right angles, hillside terraces, dedicated agricultural fields, and these incredibly advanced water management canals designed to handle heavy seasonal flooding. Researchers estimate these cities housed populations in the tens of thousands. They traded with one another and operated under regional governance structures that archaeologists are, quite frankly, only just beginning to piece together today. Part 2. Teaching AI to see, the disruptor tech. Now you might be wondering, how on earth do you see a 2,500-year-old road under the thickest jungle on Earth? Well, it starts with LiDAR, which stands for Light Detection and Ranging. By firing lasers from an aircraft or a drone down at the ground, the light slips through the gaps in the leaves and bounces back, creating a topographic map of the forest floor. But there's a huge problem. This raw LiDAR data creates what we call a 3D point cloud. It's quite literally millions of laser pulse measurements. To the human eye, it's just a giant mess of raw noise spread across hundreds of square kilometers. A human researcher could spend years staring at this data trying to spot a meaningful pattern. And this is where artificial intelligence steps in and changes the game entirely. Step 1, feed the raw 3D point cloud into an AI. Step 2, train the machine learning system on known archaeological examples. They basically teach the software, hey, this specific geometric signature is a road, this is what a settlement mound looks like, this is an agricultural terrace. And finally, step 3, the trained AI scans those enormous data sets and highlights the most promising anomalies. It takes years of a human manually staring at data and turns it into a task that takes mere days. Anthropologist Nicolas Gauthier describes this perfectly. He calls the AI a bonus set of glasses for archaeologists. Because let's face it, a human researcher gets tired, their eyes cross, they need sleep. But the AI doesn't.
It tirelessly scans every single inch of the data, acting as this ultimate truth serum and a powerful bonus set of eyes for the researchers in the field. Archaeologist Sarah Parkhook points out another massive benefit here, saying that's the real revolution of AI and machine learning. It lets us process all that data that we already have. Think of all the decades of surveillance and survey data just sitting on hard drives, completely unanalyzed because we just didn't have the manpower. Suddenly, the whole shebang becomes searchable. It fundamentally changes how we approach the past. Part 3. Mountains and Maya lowlands. A global pattern, because this magical combination of LiDAR and AI isn't just happening in the Amazon.
As we map out these civilizations across time, from the Upano Valley 2,500 years ago to the peak density of the Maya lowlands, all the way to the 6th and 11th century Silk Road mountain cities, we're seeing that massive, complex populations were thriving absolutely everywhere, completely hidden from us until right now.
For example, let's look at Uzbekistan. In October 2024, archaeologist Michael Freschetti announced an incredible discovery using drone-based LiDAR. The old belief was that major medieval Silk Road trade networks actively avoided difficult mountainous terrain. Which makes sense, right? Why drag goods over a freezing mountain? But the AI discovery completely shattered that myth. Two long-lost medieval cities, Tashbalak and Tugunbalak, were found thriving at a breathless 2,000 meters of elevation. Over in Central America, the technology revealed something equally mind-blowing. LiDAR surveys showed that the Maya lowlands had population densities far exceeding anything researchers considered feasible. They estimate there may have been up to 15 million inhabitants at their peak. Extensive highway systems, engineered and elevated above flood zones, linked urban centers across hundreds of miles. To put that in perspective, that's a population density matching medieval England, completely compressed into the tropical jungle, totally invisible from the ground.
Part 4. What else is hiding? This brings us to a breathtaking realization about the very ground beneath our own feet.
Before LiDAR and AI, archaeologists were mostly limited to sampling. You'd find a promising site, dig a small trench, and sort of make an educated guess about the rest of the region. But for the first time in human history, we're moving past those tiny educated guesses. We are now comprehensively mapping entire lost empires, full settlement networks, and massive transportation corridors all at once. We actually get to see how entire civilizations evolved across vast territories.
Sarah Parkhook captured the heart of this modern research perfectly when she said, archaeology is not about finding, it is about finding out. It's not just about digging up a single golden artifact or a neat piece of pottery anymore. It's about uncovering the massive interconnected human stories of how tens of thousands of people lived, worked, and thrived in environments we previously thought were uninhabitable.
So, as we wrap up this explainer, I want you to really think about this. How many lost cities are still hiding under the jungle canopy? How many ancient roadways remain undetected beneath the desert sand? How many settlement patterns have we missed simply because we couldn't see the big picture? With the tools finally ready and the algorithms getting smarter every day, what else is waiting in the dark for our lasers to finally speak their names? Thank you so much for joining me to explore this incredible leap in human discovery. Keep questioning, keep learning, and I'll see you in the next explainer.
Welcome to the Explainer. Today, we're embarking on a truly cinematic journey straight into the dark to unlock some of the most guarded, long-lost secrets of the ancient world. You know, for centuries, humanity has basically just stared at these artifacts, holding the greatest thoughts of antiquity, completely and utterly unable to read them. But today, well, artificial intelligence has literally just shattered 2 millennia of silence. So right off the bat, we have to ask, can we actually read a scroll without ever opening it? For generations, this was an absolute impossibility. It's kind of like the ultimate archaeological locked room mystery. I mean, how do you access the wisdom inside a super fragile artifact when the very act of trying to open it destroys it completely? Okay, let's dive into this timeline to really get some perspective. Picture this. It's exactly 2,000 years ago, 79 AD, and the Vesuvius volcano erupts. It instantly buries this vibrant seaside Roman town called Herculaneum under massive layers of ash and rock. Fast forward all the way to the 1700s, and excavators stumble upon this vast library hidden in a buried villa. But it took until 2023 to actually read a single word. That is just a staggering gap of silence. To understand why it took so incredibly long, we really have to look at what Vesuvius actually did. When the volcano erupted, these literal walls of superheated gas and ash, we're talking pyroclastic flows hitting 500 degrees Celsius, slammed into the library. But amazingly, no, the scrolls didn't burn up. Because of the extreme lack of oxygen, they carbonized. They were basically baked into these perfectly solid, yet impossibly fragile cylinders of charcoal. So for 275 years, these scrolls just sat in museum vaults. And here is the tragic irony of the whole thing. Every single time a researcher tried to physically unroll one, it just crumbled into dust. The ancient texts were right there in their hands, yet totally unreachable. Enter artificial intelligence. Modern tech basically stepped in exactly where physical archaeology had a brick wall. Today, we're going to break down these incredible machine learning breakthroughs led by the Vesuvius challenge and Google DeepMind and see exactly how algorithms succeeded where centuries of human hands failed. So the core of the problem here was the ink. The Romans used carbon-based ink. And think about it. When you write with carbon on papyrus, and then that entire thing gets baked into solid carbon by a volcano, well, the ink becomes completely invisible to the human eye. It just blends right in. It's like a giant puzzle where all the pieces are the exact same color. But, and here is where the science gets truly magical, X-ray CT scans can actually detect a really, really subtle difference in the physical density between that ink and the papyrus. And this brilliantly illustrates the whole concept of virtual unwrapping. Back in 2023, a computer scientist named Brent Seals launched the Vesuvius challenge. He released these insanely high-resolution 3D CT scans of the scrolls and just asked the world to help. So how does it work? First, you take that 3D scan. Second, algorithms mathematically trace the crinkled, crumpled layers of papyrus inside the unopened scroll. And third, neural networks are trained to spot that tiny density difference we just talked about to recognize the ink. All of this happens computationally. No human ever actually touches the fragile charcoal. Which brings us to this spectacularly thrilling human moment. Okay, picture this. It's late 2023. A 21-year-old college student from Nebraska named Luke Farator is literally at a house party. Suddenly, his phone buzzes. He opens it to check the output of a machine learning model he's been training on the CT scans. And right there, glowing on his screen, is a word. Porphyros. It's the ancient Greek word for purple. Luke had just become the very first human being in 2 millennia to read a word from inside a sealed Roman scroll, right from his phone at a party. Unbelievable. You can imagine students, scientists, programmers all over the world caught fire with this news. The idea spread like wildfire. Luke's breakthrough sparked this massive global machine learning race. You had people from entirely different backgrounds collaborating online, sharing code, sharing data, all driven by this one singular grand quest to decode the past together. And the results? By February 2024, an international team pushed the boundaries of this technology to win the grand prize. They didn't just find a few scattered letters. They decoded, wait for it, 2,000 characters. That's 4 full columns of ancient Greek text, pulled directly from the absolute darkness of a burnt lump of coal. Just incredible. So what did it say? Well, this text actually belonged to an Epicurean philosopher named Philodemus. We are now reading his previously completely unknown thoughts on pleasure, music, and the human senses. Really think about that for a second. Scroll P.H. Herc 1667 was virtually unwrapped and read from beginning to end. Across 2 millennia of fire, ash, and time, an ancient thinker is finally speaking to us again. So the crucial point here is the sheer scale and momentum of this endeavor. It's staggering. The Vesuvius Challenge has awarded over $1.8 million in prizes so far, and they show absolutely no signs of stopping. Teams are actively refining these AI models to read faster, clearer, and dive much, much deeper into the library. Let's move to and see how this builds into an even larger archaeological revolution. Because it's not just about carbonized scrolls anymore. Across the Mediterranean, historians face another massive, massive problem: broken stone. Centuries of weather, war, and just general neglect have smashed ancient Greek inscriptions into pieces, leaving these huge, frustrating gaps in our historical record. Now, what's really interesting about these numbers is how it completely redefines the relationship between humans and machines. Google DeepMind created a deep neural network called Ithaca to predict the missing text on these broken stones. Historians working totally on their own, they can restore these texts with about 25% accuracy. Ithaca, UAI, working completely alone, hits 62%. But, and here's the real game changer, when historians collaborate with the AI, the accuracy leaps to 72%. AI isn't replacing historians at all. It's a tool that, when combined with human intuition, vastly outperforms either one working separately.
And the technology is just advancing so rapidly. Fast forward to 2026, when DeepMind released Ithaca's successor, named Aeneas. This AI takes the revolution from Greece and expands its street over to Rome. Aeneas contextualizes ancient Latin inscriptions using what's called a multimodal parallel search. Basically, it cross-references damaged fragments against thousands of known Roman texts to find historical fingerprints. It's kind of like a highly advanced search engine for fragmented ancient memory.
But let's bring this all back to Herculaneum for a minute and really look at the massive stakes ahead of us. Researchers strongly believe that the villa where the scrolls were found actually has a second, completely unexcavated library. A much larger one. If we dig it up, what might we find? I mean, we could uncover the lost plays of Sophocles. We might find unknown works by Aristotle that we know existed but have literally never actually read. Plays by Euripides. We could even recover entire schools of ancient philosophy that were completely wiped out when the Roman Empire fell.
Which really leaves us with this final, thrilling question. Just imagine, if we can pull the thoughts of an ancient philosopher out of a single burnt scroll, what else is hiding in the thousands of scrolls still waiting in the dark? History is never truly silent, guys. For 2,000 years, the ancient world has just been waiting for us to catch up. And finally, through the power of artificial intelligence, we are learning how to listen.